welcome to the podcast of the European Young Chemists Network, EYCN. My name is Mark Carrada, and welcome to our new series. In this series, we interview the winners of the prestigious European Young Chemist Award 2020 to discuss with them their research and also ask them for advice for other young chemists. Today, we are talking about how we can enable novel reactions with the application of sound, which could allow for more eco-friendly processes in the chemical industry. For this, our Austrian delegate Miguel Steiner interviewed the silver medal winner at the early career research level, Dr. Gregory Chatel. Dr. Chatel received his PhD degree in 2012 from the Grenoble Alpes University in France. He then joined Professor Rogers' group at the University of Alabama as a postdoctoral research fellow. At the end of 2013, Dr. Chatel came back to France and joined the IC2 MP at the University of Poitiers in France as an assistant professor, and in 2016 he joined the LCME at the University Savoie-Mont Blanc, where he performed research in green chemistry and sonochemistry for biomass and waste valorization, as well as processes of fine chemistry. Upon completion of this, he became an associate professor in 2018.
So hello everyone, it's my honor to greet Professor Dr. Gregory Chatel from the University of Savoie-Mont Blanc here with me today. And we're going to talk about sonochemistry a bit. So Gregory, congratulations again to the EYCA, and thanks for the interview today. And my first introductory question would be, what motivated you to go into chemistry? And also, how did you end up in the specific field of sonochemistry?
Thank you. In fact, during my studies, I particularly discovered the concept of green chemistry of John Warner and Paul Anastas, and I really wanted to work to make chemistry greener, more environmentally friendly, more eco-compatible, bring innovation in this field. So I started to work on sonochemistry during my master internship. I finally studied ultrasound for organic chemistry during my PhD. So what is exciting in this field of research is that we can find totally different or new reactivities under ultrasound compared to conventional conditions. We can imagine new reactivities, new innovations with sonochemistry, and that's what is motivating.
Okay, great. So maybe for the listeners, so sonochemistry describes doing chemistry with some application of ultrasound. And I guess most people have encountered ultrasound more in like a doctor's office for inspecting organs or joints. And could you maybe highlight how this ultrasound that you're using in a chemistry laboratory might be similar or different to the one that people have already made experiences with?
Sure. So in our lab, we make chemistry with sound. It is not really music, but it is ultrasound. Ultrasound rays are not in the audible region, but in ultrasonic region that can be divided into two distinct regions. The first one corresponds to diagnostic ultrasound, particularly used in medical imaging. The corresponding rays do not provoke modification of the medium. It is better for the organs. But the second region is power ultrasound that we use in chemistry for sonochemistry from 20 kHz to 2 MHz. They provoke some effect on the medium, in particular through the cavitation phenomenon, which is the formation, the growth and the collapse of gaseous microbubbles in the liquid phase, leading to intense local effects that we use in sonochemistry.
So while both are categorized as ultrasounds, yours has a way higher frequency and has a way bigger influence on the water that is used as a solvent. Is this correct?
Yeah, it's correct.
And what are the main advantages of doing chemical reactions with this bubbly water compared to like a standard approach that one would
What
do in a
is famous
chemistry
in
lab?
sonochemistry research is that each sonochemical parameters can affect the cavitation phenomenon and the associated effects. And for example, it is usually accepted that in water, low frequencies lead preferentially to physical effects with shock rays, emulsions, mass transfer improvement, and at high frequencies, the cavitation leads to chemical effect with the production of hydroxyl radicals. So the intense local effects, mechanical, thermal, and chemical effects due to the collapse of the bubbles are at the origin of all the application of sonochemistry. In addition, the local hotspots liberate intense pressures and temperatures. And for example, in organic sonochemistry, the main advantages provided by ultrasound are the decrease in reaction times, the increased reaction yields, the use of mild conditions, for example, lower temperature leading to energy savings, the change of reaction pathway leading to new reactivity, the reduction of amount of catalyst, the activation of metal solids, or solids, and also the generation of useful reactive species. So it is important to control all the parameters, the frequency, the acoustic powers, and other experimental conditions. And another parameter that is essential is the reactor. The shape of the reactor have a great importance since we are speaking about the propagation of waves in a reactor. So it is important.
So those are really a lot of parameters to handle. So one has a lot more things to consider, but also a lot more possibilities. Is this kind of the reason behind the big advantages?
Yeah, it's correct.
And as you already said in the beginning, you're also mainly working on green chemistry, which is a field that focuses on the prevention and better use of raw material, better waste management, energy savings, and also to use solvents which are more eco-friendly. And you and also other researchers have pointed out that sonochemistry and green chemistry have a strong connection. Could you maybe explain where this strong connection comes from and why sonochemistry is so interesting, especially for green chemists?
Yeah. Green chemistry and sonochemistry are both multidisciplinary. The eco-friendly processes based on ultrasound have been reported in many fields such as sonocatalysis, organic chemistry, preparation of materials, polymer chemistry, biomass conversion, extraction, electrochemistry, and also environmental remediation. So it is really multidisciplinary. As I mentioned, the advantages of sonochemical processes are the improvement of kinetics, the reduction of the amount of catalyst, the work in water as solvent, and other improvement in terms of green chemistry. For example, the use of sonochemistry for biomass valorization is an interesting field in link with green chemistry. The ultrasound irradiation are mainly used as pretreatment and extraction method to replace the use of unfriendly chemical or harsh conditions, and can provide the necessary energy to treat biomass. From my side, I especially work on the production of chemicals from biomass and waste through new reactivity provided by sonochemical activation. In addition, it is really difficult to identify clear trends in the literature, except the improvement in terms of reaction time reduction, yield or mass transfer effects compared to silent conditions, and the use potential that sonochemistry can bring in this area. So the current challenge is to understand how ultrasound can be beneficial during the biomass conversion processing and to understand all the mechanisms in these reactions.
So in a sense, the ultrasound is more of an eco-friendly way to bring more energy into the system compared to the standard methods in the chemical industry right now, like very strong heating.
Yeah. And we can also imagine new opportunities, new reactivities. So.
And you also already went a bit into this way. So what do you think if it comes to chemical industry? What would be the best applications of ultrasound? And do you think that ultrasound will be used in pretty much most industrial processes in the future?
It's a good question. This is currently the biggest challenge in sonochemistry. Ultrasound is industrially used for welding or cleaning applications, but still not very little in sonochemistry. Currently, research concerns the transposition of the excellent result obtained at lab to develop them on a larger scale. The extrapolation of data collected at lab is now possible through different software and through the development of new sonoreactors, extraction, biomass valorization, also specific organic reaction are for me the best candidates for large-scale application in the next future. And we are working for that, especially through the development of continuous processes at lab.
And do you have any time estimates? And what do you think are the biggest issues to overcome both in the research field and also in the practical application in industry?
I hope very soon. We are also filing patents in this direction, actually. One of the problems is that sonochemical processes require new equipment, and industrial companies want to be sure of the added value before investing in less conventional equipment, because for now they don't have this kind of equipment.
So it imposes additional risk factor for companies to invest in such a new process.
Yeah.
Okay, so thanks a lot for highlighting your research. In this mini-series of interviewing all the EYCA winners, we're also asking a bit about career advice that young chemists can take for themselves. So what are your further goals in your career?
In addition to my research activity, I am also a teacher at the university. It is great to teach students new concepts, to share my job, my passion. Another aspect that I like a lot is communicating with the general public or with school children. I attend to this kind of events, and it is also an interesting exercise to explain our research to the general public. I really think it is our duty to communicate on our research, on scientific advances, to explain, to alert, to teach the general public.
Okay, thanks a lot. And when you teach, are there any special advices that you give young chemists in general for their career and for their research?
Experiment. Don't be afraid to innovate and test new ideas. Do not hesitate to collaborate, to learn more from other chemists, other chemistries, and share your ideas with different collaborators, because we are scientists and we are not alone in our job. We have to work with other scientists, even through multidisciplinary approaches, and I think it's great to work in this sense.
Yeah, definitely agree with you there. And could you give maybe also special advice to students that are not really sure in which field of chemistry they want to specialize in? And also maybe the other side of the students that already pretty exactly know where they want to specialize in.
For those who do not know in which field to specialize, I think it is important to be able to do internship in different fields or work on different type of projects. It allows you to know what you like and also what you don't like, and you have to practice, in fact, to know if you like or not. For those who know, do not hesitate to look the different research activities of different laboratories. you can contact them, discuss, and also ask them for an internship. I think it's the best to practice.
So practice is the best education. And which advice would you give PhD students, both that just started their PhD and those that are finishing their thesis right now?
The advice that I could give for a PhD student at the beginning, during, and at the end of his PhD is to develop his network. Because the chemical community is very small, especially in each research field, the network can open new opportunities for young chemists, maybe in 1 year, 2 years, or even in 5 years. So my advice is to develop and use your scientific network and stay open with that.
And I think that's a really nice ending to this interview. So thanks a lot again for sharing your research in the EYCN podcast and also for giving such great advice to young chemists in general. And we wish you all the best on your further career. And thanks again for taking part in this interview.
Hello, it's Mark here again. We hoped you liked the third edition of our new series. Stay tuned for the last winner and feel free to listen to the previous editions. Please, as always, leave your feedback by rating our podcast, and if you have any questions or further remarks, you can also send us an email at podcast@eycn.eu. See you soon.